Welcome back, citizens, to the very basic refrigeration series. Today, I'm going to have a little chat about paddle flow switches. The reason being, I've come across hundreds out in the real world, and they've all failed for practically the same reason. So, hopefully, we can put that right. Well, paddle flow switches, saying probably the most important safety switch on a water chiller. Safe for the water chiller, not necessarily for you, but is very critical. We're going to talk about the choice of switch, the assembly of the switch, the position of the switch, and then do a comparison with pressure differential switches. Here we have the pretty standard flow switches available from your favourite wholesaler. As you can see, you've got the main body, you've got your different length paddles. You can actually get paddles longer than that, which you can trim with a stout pair of scissors or a pair of snips and the mounting screw. Now, they all seem to come along with 1-inch BSPT screw thread, which we know BSPT stands for British Standard Pipe Taper, so therefore you're going to need some sealing compound or some PTFE tape, and we know that PTFE stands for plastic tape fixes everything, or polytetrafluoroethylene. And the other thing to take into account and to consider is the IP rating of the switch. Now, you really need quite a high IP rating, because if that's sitting on a chilled water pipe, then the cold from the chilled water is going to transfer up the body of the switch here, and then the insides of the switch are going to get very cold. So if you haven't got a very high IP rating, then you're going to get condensation forming inside the switch, and pretty soon it'll all start rusting. So let's consider the installation of the switch. Here we have a representation of a paddle switch. If you notice, we've chosen an 1.25 inch socket to be welded onto the pipe, and the reason for that is because we can then screw a 1 inch to 1.25 inch reducing bushing, and that gives us a better clearance between the paddles and the sides of the socket so that they don't get interfered with. Now, another thing to consider is when you're assembling the paddles, you need to decide the length of the paddles that you need, and if you're, for example, needing to use the longest paddle, then what you need to do is to mount all the other paddles before it, which stiffens that against the water flow. If you'd have it the other way, this would just flap about, and eventually it would end up snapping off the paddle. As I say, I've come across loads and loads of these, and they generally fail because of one or two reasons. One is that the paddle's failed because it hasn't been fitted properly, or you've got condensation within the flow switch box and it's all started to rust. Here you can see the flow switch assembled, and all you need to do now is when you seal it into the pipework, you need to make sure that it's facing the right direction for the flow. And here we can see the best position for the flow switch on the outlet of the evaporator, hopefully on a straight piece of pipe and not too close to any valves or any bends. And the reason that we put it on the outlet is it's the only way that you can actually guarantee there is flow through the evaporator, is to have the flow switch on the outlet. So just to do a comparison between the flow switch and the pressure differential switch, as we see here, you can see, for example, that the switch is in the middle there, and you have the higher pressure connection on the water inlet, and you have the lower pressure connection on the water outlet. The reason being because the pressure drop across the evaporator causes the pressure differential. Now that's fine all the time that everything's working all right, but what happens if you were to get a blockage within the evaporator? For example, I don't know, some debris or something that's blocking it, or even worse, you get a freeze up and you don't have any water flow. Well, you've still got a higher pressure on the water inlet because the pump's running, and a lower pressure on the water outlet. So it's not a great idea, and to my mind, flow switches are a lot better. Well, I'd like to thank you all for watching, and I hope very much that it helps. And if you thought it was useful, maybe give it a like. And if you would like anything specific to be covered, please put it in the comments below, or you can email me at david.finleynh3@gmail.com. Well, happy refrigerating, citizens.